Yeah, so here's going to be an example of something that you that could be about Gramm-Schmidt. So share screen. Okay, restart. Let me take some vectors. Yeah, so this is an example I did. Let's put I did this example 5. Yeah, this I did. I already did once. So let's just say -2, and then here 5. Yes, 7 or something. Okay. Okay, so these W's are in the form 1, 0, 0, 0, 1, 0, 0, 0, 1, and then something here. Yeah. The W's could be a nice basis of the range of A for some 4x4 A with dimension of the null space equal to 1. Discovered from consistency conditions. From a consistency condition in this case, after a forward pivoting phase without scaling. Okay, and what we're going to do is a column sweep to create orthogonalities. And so we're going to change the second one to make it orthogonal to the first one by subtracting a multiple of the first one from it. And then we do the same thing with the third one. Okay, and then we have a new second and a new third one, which are orthogonal to the first one. Okay, and then we take the second one and we do the same trick with the third one. Take a multiple of this one, subtract it from this one to make these two orthogonal. Yeah, so it's a column sweeping to create orthogonalities. It's only forward in one direction, and there are no zeros to be created and no pivots to be used. Here's the first one. Okay, now we modify the second W1, W, take inner product with the first V. The first V was just created, well, it's the old W1, but we think of it as the first V. And what is the inner product? Yeah, that's the inner product, yeah. This is V1 is W1, so that's the inner product of these two. So 1 times 0, 0 times 1, 0 times 2, minus 2 times 5. Here it is, it's minus 10. And there's also the inner product of V1 with itself. That's 5. Minus 10, 5. Okay, now the quotient of these two is, yeah, this is an old calculation, it's not, it's minus 10. 5. That's 2. Okay, and now what we're going to do is this command. Yeah, I'm a bit handicapped here. So this says V2 has to become the old V2. Sorry about that. It has to become this one. W2. Well, maybe now I can write it like this. Maybe it doesn't protect. It really, what if I do this here? Ah, yeah. So V2 becomes W2 minus, and then in the numerator, the inner product of W2 and V1 times V1, and in the denominator, the inner product of V1 with itself. So read brackets here. And with this minus 2 here, that's equivalent to put in plus 2 here. And let's see if the inner product is right. Yeah. So what I do here, this command here, I do this with, this is just the sum of the sum of 1, 2, 3, 4. I is 1, 2, 3, 4. It's 10. Yeah, if I do this number, and if I take these entries here, then I get this 30 here. So that's just a command to take the products and take the sum. Yeah, and now I do for, what do I have now? Now I have V1, V2, W3. And now I do W3 with V1 exactly the same thing. Yeah, so I take the inner product of W3 with W1, okay? And I take the inner product of W1 with itself. That's this 5 here. And then this one with this one is going to be 1, is going to give me minus 2 times 5, that's 10, minus 10. So I'm going to get exactly the same. Yeah, so here we go. This is V3, the new V3. And if I now take the inner product with 0 and V1, V2, and V3, yeah, these are all new now. V1 was the original W1, and V2 was the original, is the modified W2, and V3 is the modified W3. This one, the final one, still has to be modified to make it perpendicular to this one, because it's already perpendicular to the first one. Okay, so copy the previous command with 3 and 1, but now with 1 replaced by 2. That's this one. Okay, so now we have the final. Okay, and now, and these are all orthogonal now. And if you like, you can say I don't like these denominators here. So I take 6 times 3. Yeah, so this is something in which you have to take a given set of vectors and turn it into a set of orthogonal vectors. And yeah, okay, it can be given that it's a basis. And if it's not a basis, then on the way you lose vectors. Just like on the way to in row sweeping, you may lose equations. Okay, so let's say, yeah, so so this Gramm-Schmidt with a special set of vectors. Yeah, so clearly this special choice here makes that you will not have to do terrible calculations. The inner products are all very simple, etc. So I think this is reasonable for an exercise. And it's also important because, yeah, so the range of A in this description will turn up in stuff that we do with A and its transpose, but this is not treated so far. Stop sharing and